Dear learners, I am Ritesh Kumar Ravi, Assistant Professor. Today, our agenda is to discuss about a program to perform all arithmetic operations. It will be a lab number 6. This will be a lab number 6, and hopefully you have already learned about the basics of the programs like addition, subtraction, multiplication, and division entirely. So today our agenda is to perform all the operations, arithmetic operations means addition, subtractions, multiplications, and division add on with it. In computer science, C programming languages like a modulus, which is also known as a remainder values. So, first of all, what we have done, we have added the comment line for representing the programs that we are doing right now. And it is a general habit that I requested you all to put the values are like this. And similarly, I have done it with the name of a lab number 6 C program to perform all the arithmetic operations. Now, the question is, sir, how to do it? For that, we need a basic header file that we are keep on adding like has include studio.h and has include conio.h. As we know that studio.h is required for performing the input output functions like printf and scanf, and the conio.h is utilized for adding the clear screen, means whatever be the previous input on the screen must be cleaned, and for get ch for holding the screens. So you can do it by removing, because if you want to understand, you can do it by removing the clear screen and get ch whether the screen is holding or not, as I have already shown you. So now our agenda is to discuss about it. For each and every program to execute perfectly, we need a main function, and it is my general habit to put the main functions with the return value as an integer. And accordingly, you know that whenever we write the program, first of all, int main will return a value right now 0. And we will add something different when we will discuss the function concept while doing the lab programs. So after this, we have added the clear screen, and clear screen, as I told, for clearing the previous inputs of the display value. Then after, we have added the two user input values. So if you want to put, we can write it here, a user inputs. We want to put user input, user input, user input. And we know that for user input, we need a declaration, user input and declarations. So we have a declare the values are like this, and that declaration will have at least two numbers as a user input. And the result of this user input will be stored in subtractions, summations, multiplication, and mode value. But the float value may have a decimal points, and hence we have taken the float as a data type. So integer, integer, and in float. These are the data types of the declarations which may required in the coming programming sections. So let's see how this can be utilized. So we have taken the two inputs from the user by printf enter any two numbers. So this is for the display for the users that you need to enter the two numbers, and if you want to add a slash n, we get slash n also added will be there, which is a good practice for, and visibility also. And after that, scanf for the user input, it will take the two numbers num1 and num2 with the address value, means at that address whatever be the value you enter will be kept on storing, and the return type is since integer, so we can have ampersand d and ampersand d for the representation of that integer. Now after for performing all the operations, we can see over here whatever be the input you have put at there, there will be additions of the two numbers, num1 plus num2, and will be stored in sum. Likewise, and what is that sum? Sum is the declarations which will be storing the result after adding these two numbers. Just after that, we will subtract num1 minus num2. The same operations we have already done in the lab number programs like third, second, fourth, and fifth. So we can see over here num1 minus num2, num1 into num2. Importantly, a division will have or may have a decimal or a fraction value. So we have done here the data type change, or it is called also as a type conversion. So what I mean, however it is an integral values, we have converted the result of these values into the float. So it is very much important for your understandability purposes. So if you want to convert the integer numbers into the respective floating point numbers, it is important to convert it into the float by this type conversion. And then a mode operation is again an integer type, so there is a not required any kind of type conversion. So what is this percent means? This percentage will be giving the a remainder value of any division, means if we divide 3 divide by 2 or 5 divide by 2, so there will be a quotient which will be stored in the division part. But if it is about the remainder, so 5 divided by 2 will be having 1 as a remainder and 2 as a quotient. So 2 will be stored at the division section, and the mode means remainder will be stored at the mode value, and always it is coming in integral values. So there is a no change or not required any change of any fractional value. So that's it, the main concept or the logic which I am talking about while doing or performing any program. So this is the main logic that you must remember, and this is what we require the declarations, and we can see that all the declarations have been utilized. The declarations what we have done over here, or what we have done over here, has been utilized at here. Now it is the time to show the results. So printf is the best way to show the results. For that we have just put the value with the declaration value as a sum for showing the value of addition of two numbers. And difference is for subtracted value with the declarations of sum, product value for multiplications, quotient value for a division, and modulus. We can also write it as a remainder value. If you want to write, you can, because if we have write modulus over there, then quotient can be, then a remainder can be also, a remainder can be written, a remainder can be written over there. So remainder can be written for the modulus value, and eventually they get ch function and return 0, as I told for the int main, since we are nothing returning over here, so by default we are returning as a 0. If we read a void over here, then even the return function is not, return value is actually not required. So it is a time for compilation. Obviously, Alt F9 is the best way, and fortunately, we have no error over here, and that is the best part of this program. And I told that how is it possible? You have to keep on doing the task or adding the codes step by step. Like first of all, write the int main function and then CLR as CR get ch and return value as 0, and write some printf value like what I have done in the previous programs also. And then after, just add the programs, write the user inputs and see whether it is taking the user inputs or not. So after writing the logic or performance of the programs, just check whether it is working or not, and one by one printing the values and showing the results. Since it is a little bit a bigger program, so I request you to take a snap or pause yourself and see how exactly this program has been written properly. Now it is the time for compilation. So Alt F9 is best way to compile and there is no error. We are lucky enough and a good programmer having this is kind of output. So enter two numbers. Any numbers you can say. I'm taking a small number because it is very much easily calculatable. So I have taken 5 as a first number and 2 as a second a number. Now tell me what will be the addition value or what are you expecting the addition value of it? Obviously summation will be showing 7. What will be the subtracted or the difference value? Obviously it is 3. If I talk about multiplication, so 5 into 2 becomes 10, which is also an integral value, that's fine. But what will be the value of division? So 5 divided by 2 is going to give the quotient value as 2.000, and if we take the entire values, it may have actually 2.5. But again, the modulus value will be, or the remainder value that is also known as, will have a value as a 1. So I'm just entering for results. So you can see the exact result of 8, like sum is 7 as per the expectations, and difference is 3, product is 10. Quotient, since we have converted into the float, so it has come like this as this one. So I'm just putting the value as a 5 and then 2. So we can see our quotient is having 2.5 and 000, and remainder or the modulus value is 1. Hopefully, and this program is very much understandable and you have got the clear idea that how the program has been done. I'm summarizing it quickly. So this is a program for performing all the arithmetic operations, and in computer science C programming we have actually 5 types of operations like addition, subtraction, multiplication, division, add on with a remainder or a modulus operations. For that I have included the header files, and then after the main file program has been written to call each and every function, either it is a user defined or a system defined like printf scanner. Accordingly, we have done the declarations for the programs that may require in the further coding aspects, especially in the logic. And that's what I have done in the logic part. And eventually, we have displayed the values of each and every 5 types of basic operations of arithmetic, and eventually we have returned the value 0, and hence we can take any value. Right now I'm just reverting the numbers like 2 comma 5, so negative numbers can be also seen with the value, and hopefully it is very much understandable, like 2 plus 5 is 7 again. Difference 2 minus 5, since minus is having the higher value, so negative sign will be there, and accordingly 2 into 5 is 10. Quotient is 0.400, as you can divide and see the result, and remainder obviously 2 divided by 5, so no further divisible is possible, so remainder is 2. Hopefully you got it completely, and this program is now very easy for you to understand and get the hands on this program and be a good programmer. So thank you so much, dear learners. Enjoy learning.